Welcome to our factory. Today, I'll show you how massive wind turbines are made, step by step.
These towering giants are the engines of the green energy revolution, capable of powering thousands of homes. But before they touch the sky, they begin here on the ground, constructed from basic raw materials with microscopic precision. Over the next 16 minutes, we will take you on an exclusive journey from raw steel and fiberglass to a finished megawatt power plant.
It all starts with the foundation of modern engineering, raw steel and advanced composites. Let's begin.
The journey begins in the steel yard. Thousands of tons of heavy-duty steel plates arrive daily by rail.
These plates, up to several inches thick, will form the backbone of the turbine, the towering mast. Meanwhile, in a highly controlled environment, miles of fiberglass and carbon fiber fabrics are prepared. These lightweight yet incredibly strong composites are the secret to crafting aerodynamic blades. We also rely on balsa wood and advanced structural foams. These materials provide rigidity to the blades without adding excessive weight. The chemical composition must be precise. Even a fraction of a percent off can compromise the turbine's structural integrity. To bind the composite materials together, specialized epoxy resins are mixed in massive industrial vats. For the generator, pure copper wire is essential. It arrives in massive spools, ready to be wound into coils. Lasers continuously monitor the thickness of the copper. Optimal conductivity is crucial for maximizing electrical output. Rare earth materials, specifically neodymium magnets, are brought in to create the powerful magnetic fields required for power generation. These magnets are so powerful that they require specialized, non-ferrous tools just to safely unpack them. With raw materials prepped and inspected, they are routed to 3 distinct production lines. One path builds the tower, another crafts the immense blades, and the final path constructs the complex nacelle. Let's follow the steel first, as we construct the foundation that will hold everything hundreds of feet in the air. The transformation from raw metal to engineered masterpiece is about to begin. The massive steel plates are cut to exact dimensions using computer-controlled oxy-fuel torches. These rolled cylinders, known as cans, are the individual building blocks of the turbine tower. Overhead laser projectors guide the technicians, ensuring the composite layers and balsa wood core are aligned perfectly. Meanwhile, in the blade factory, the process is delicate. Workers carefully lay dry fiberglass fabric into a gigantic mold. A single blade can be over 80 meters long. Every layer must be placed precisely to ensure structural balance. The balsa wood core is laid down, providing immense stiffness while keeping the aerodynamic structure incredibly light.
Once all dry materials are in place, the entire mold is sealed in an airtight vacuum bag.
Vacuum pumps remove all the air, compressing the layers together with atmospheric pressure.
This triggers the vacuum infusion process. Liquid epoxy resin is literally sucked through the dry fiberglass. The resin completely saturates the fibers without leaving any microscopic air bubbles, guaranteeing maximum strength. The infused blade is then baked in an enormous curing oven to harden the resin into a solid, unbreakable matrix. Back in the heavy metallurgy division, molten cast iron is poured into precise sand molds. This forms the hub, the crucial central nose cone that connects the spinning blades to the main shaft. Once cooled, computer-controlled CNC machines mill the hub, drilling bolt holes with micrometer accuracy. Simultaneously, the gearbox is assembled. This complex mechanism will convert the slow rotation of the blades into high speed. High-performance lubricants are applied to planetary gears, ensuring they can withstand extreme rotational torque. The heart of the turbine is the generator. Here, specialized technicians hand-wind thick copper coils into the stator.
This massive ring of copper and magnets will soon turn wind energy into megawatts of electricity.
Now, the pieces begin to come together. The rolled steel cans are stacked to form larger tower sections.
Robotic welders fuse the cans together in a continuous, seamless operation, ensuring zero structural weaknesses.
Inside the tower sections, technicians install safety ladders, platforms, and high-voltage cable trays. The completed tower section is moved into a shot blasting chamber, bombarding the steel with tiny metal beads. This process removes all impurities and creates a perfectly rough surface for the anti-corrosion paint to adhere to. Back in the composites hall, the cured blade halves are ready to be joined into a single aerodynamic wing. A specialized, high-strength structural epoxy is applied along the leading and trailing edges. In a feat of heavy engineering, an overhead crane lifts and rotates the upper half of the blade. Inside the nacelle assembly area, the massive forged steel main shaft is lowered into its bearing housing. Next, the heavy-duty generator is carefully coupled to the high-speed output shaft of the gearbox. The gearbox is bolted to the main shaft. It steps up the slow rotation of the blades to a high speed for the generator. Hydraulic torque wrenches are used to secure massive bolts. Human strength alone is nowhere near enough here.
At the base of the nacelle, yaw drives are installed. These motors will rotate the massive turbine to face the wind.
Miles of electrical cabling and complex control systems are integrated, turning the nacelle into a smart power plant. Any imperfection, even a millimeter thick, can cause aerodynamic drag and reduce the turbine's efficiency. Specialized teams manually sand the seams and leading edges, creating a perfectly smooth, aerodynamic profile. The blade enters an automated booth where robots apply multiple layers of specialized polyurethane coating. This coating protects the composite material from extreme UV radiation, rain erosion, and ice buildup. The steel tower sections receive an equally robust treatment: thick layers of marine-grade anti-corrosive paint.
For offshore turbines, the lower sections receive specialized coatings to withstand decades of harsh, saltwater exposure.
Back in the assembly hall, the fiberglass canopy is lowered over the nacelle, sealing the machinery from the elements. The hub is now fitted with pitch bearings. These massive rings will allow the turbine to angle its blades into the wind.
Pitch motors are rigorously tested. By changing the blade angle, the turbine controls its speed and protects itself during gales. After weeks of intense manufacturing, the three primary components, the tower, the blades, and the nacelle, are complete.
But before they are allowed to leave the factory, they must face one of the most rigorous testing protocols in the world.
Quality control begins with the steel. Every single weld on the tower is inspected using ultrasonic testing.
This technology peers deep inside the metal, ensuring there are no hidden cracks or microscopic air pockets.
The blades undergo a brutal static load test. Giant hydraulic cables pull the blade to simulate extreme wind pressure. The blade flexes incredibly far without breaking. This elasticity is what allows it to survive hurricane-force gusts. Hundreds of internal sensors feed data back to the engineers, confirming the blade exceeds all safety margins.
The fully assembled nacelle is plugged into a diagnostic grid to undergo a complete functional simulation. Generators, cooling systems, and yaw motors are pushed to their limits to ensure flawless operation. Advanced telemetry systems are installed. Once operational, this turbine will stream live performance data 24/7. Each finished blade is carefully weighed. A set of 3 blades must have perfectly matching weights to prevent severe vibrations. If a blade is even slightly off, technicians add precise counterweights to the root to achieve perfect balance. At the base of the blade, a ring of high-tensile steel bolts is installed, ready to mate with the pitch bearing. With testing and balancing complete, The critical connection points are capped and weather-sealed for transport. Heavy steel transport frames are bolted to the tower sections to prevent them from rolling during transit.
Outside in the logistics yard, an army of specialized transport vehicles waits to deploy the giant components.
The massive nacelle, weighing over 100 tons, is carefully lowered onto a multi-axle heavy-haul trailer. Heavy-duty tension chains lock the payload in place. Moving a power plant wheels requires extreme caution. Moving an 80-meter blade requires tandem crane lifts and highly specialized trailers that can steer independently. These unique trailers allow drivers to navigate tight corners. Highways were never designed for such length. These unique trailers allow drivers to navigate tight corners on highways that were never designed for such length. Every single component receives a final digital barcode, tracking its journey from the factory door to the wind farm. Due to their immense size, transport often happens in the dead of night, escorted by police to clear the roads.
The logistics of wind turbine transport are a marvel of modern planning, requiring route surveys and sometimes road.
Gargantuan port cranes transfer the heavy components from the trucks into the holds of massive cargo ships. The delicate blades are stacked in custom-built racks on the deck, secured against the violent motion of the open ocean. With the final nacelle secured, the cargo ship is fully loaded and ready to sail to the installation site. Whether destined for a windy plain or a turbulent sea, the components travel hundreds of miles to their new home. Upon arrival at the site, specialized jack-up vessels with towering cranes take over the installation. The tower sections are stacked and bolted onto the pre-installed foundation, rising high above the waves. The nacelle crowns the tower, housing the generator and gearbox hundreds of feet in the air. In a breathtaking maneuver, the fully assembled rotor, the hub and all three blades, is hoisted into the sky. Technicians suspended in harnesses guide the massive rotor onto the main shaft, securing it with hydraulic bolts. The mechanical installation is complete. But before it can generate power, final commissioning must take place. Engineers inside the nacelle power up the control systems and connect the turbine to the electrical grid. Software runs hundreds of diagnostic checks, ensuring the yaw and pitch motors respond perfectly to commands. Inside, the gearbox accelerates this slow rotation, spinning the generator at over 1,000 revolutions per minute. Electricity flows down the tower, through undersea or underground cables, and directly into the power grid. From raw steel and liquid resin, a marvel of modern engineering has been born. Routine maintenance ensures these giants operate at peak performance for their 25-year lifespan.
The entire wind farm is monitored 24/7 from advanced control centers, optimizing blade angles for maximum efficiency.
If storm winds reach dangerous speeds, the system automatically feathers the blades, stopping rotation to prevent damage. Generating clean, renewable energy, without a single drop of fuel or ounce of emissions.
And that is how we transform raw materials into the towering wind turbines that power our world.
From the immense heat of the foundry to the precision of composite engineering, it is a testament to human innovation.
If you enjoyed this journey inside the modern factory, there's plenty more to discover.
Join us next time as we explore another incredible manufacturing process that shapes our modern lives. This turbine does not stand alone. It joins dozens, sometimes hundreds of others, forming a massive power plant.
Don't forget to like, subscribe, and hit the notification bell so you never miss an episode. See you next time.